Hello, I'm Todd Grimm, one of many advisors for RAPID TCT 2022. What a great event, but it was exhausting. We spent that week in Detroit for the annual RAPID TCT conference, and it felt good to return to a full-fledged event in terms of the number of attendees, the number of participants, keynotes, workshop leaders, and presenters, and also the number of exhibitors. And you could feel the enthusiasm reverberate through that convention center. There was a lot going on with a packed agenda, but I'll be focusing on the additive manufacturing wares on display with this recap of show floor highlights at RAPID TCT 2022. I'll be covering hardware, materials, software, post-processing, and inspection. For brevity, I will not discuss those items that were covered in my pre-event video, which you can access on SME's YouTube channel, which I've got a link here on screen. Before I dive in, one last note. This is not a comprehensive update on all things new. To spend as much time on the show floor as possible, I sat in on the keynotes but did not join the presentations, panel discussions, or workshops. Taking time for lunch and a few one-on-one meetings, I had about 14 hours on the show floor, and yet I still did not have enough time to visit all the booths. So this is a highlight video from the things that I was able to see and discuss. Let me start with hardware. And to start that category, I'm going to focus on Filament Innovations. Now, it's tough to stand out in additive manufacturing with so many players and solutions, but Filament Innovations did just that, and they created a lot of buzz. How did they do that? By printing prosthetic check sockets for below the knee on the show floor in just 90 minutes. They were in the Mitsubishi Chemicals booth with its Icarus Gen 5, building the check sockets in Mitsubishi's PET-G. Now, the Icarus Gen 5 is a high-flow 3D printer, approximately 2 pounds per hour. And it's a substantial machine with an envelope of 460 by 380 by 950 millimeters. And you don't have to spend a ton to get these results. Icarus Gen 5 sells for just $31,000. And now I'll move on to metals, with a new player in the additive space, at least new to the US, and that's JEOL, or as they say in Japan, JEOL. This is a 70-year-old company with a wealth of products in electron microscopes and electron beam lithography systems. It had its U.S. launch of its electron beam melting system called the JAM, or JAM 5200 EBM. The system targets production applications and addresses the inherent need for repeatability. It also minimizes waste through greater powder reuse and is an open platform, giving you access to 7 or 8 parameters that you can change to meet your output goals. One thing I found quite interesting, being a new player in the US, coming from Japan, is that they have in operation 180 field engineers. Now, those field engineers are there to service the e-beam lithography systems, but they can quickly learn the additive component for the JAM 5200 EBM. I was told just 1 week of hands-on experience with the machine, and they're ready to support you in whatever region of the United States you may hail. They also have multiple parts depots already in place. The specs for the machine: 6 kilowatt e-beam, an e-shield, so no helium is needed, a long-lasting cathode running for about 1,500 hours, auto e-beam correction, it heats up to 1100 degrees C, and the build chamber is 250 millimeters in diameter by 400 millimeters in height. And sticking with metals, maybe a bit of a surprise, 3Dgens. Now, this is an FFF machine company, fused filament fabrication, that's very focused on providing industrialized solutions. This year they launched 2 more platforms that incorporate or augment the industrial approaches and an auxiliary solution for its polymer systems. That auxiliary system, Material Management System, MMS. And they launched a family of metal additive manufacturing machines. Let's start with MMS. This is a smart material handling cabinet that does 3 things. It manages humidity levels, it preheats filament when needed before entering the FF machine. That's a common need for high-temp materials like PEEK, and it can anneal the polymer also when needed before it gets to the machine. Supporting its drive to meet the demands for production, MMS gives you traceability from spool to machine and then on to part. Now on to its new printers, the MPX 260 and 260X. These are designed specifically for MIM, metal injection molding, or CIM, ceramic injection molding companies, to address the need for part and process confirmation prior to cutting molds for production. To satisfy the requirements of a MIM house, they're running with small nozzles to yield feature detail and finish that's expected of MIM production parts. What they are doing is providing a part that is processed exactly as it will be in production, which means that they have a fast, low-cost way to dial in shrink compensation and tune other aspects of the process to offer a predictive solution. And therefore, a MIM house can go straight from prototype to production with confidence. The MP260 works with stainless steel, 316L, and ceramic. Now, the X version is unlocked, so that's the MP260X. Unlocked meaning that the MIM house can run its own feedstocks. This is important because MIM houses not only use materials beyond 316L, but they also use a variety of formulations, often custom or proprietary. So whatever they plan to use in production, they can have the same straight-to-production confidence. And then on to the MP350, which is for a broader market, still metal additive manufacturing, beyond MIM. The differentiator for this machine versus competitive FFF, metal additive manufacturing machines, is that they have materials qualified that may not be available from other platforms. Yep, you can do 316L and 17.4pH, like many others, but it also offers some qualified materials that you may not find elsewhere. For example, aluminum oxide, specifically Al2O3. In steel, they have H13 and D2. Super nickel alloys, Inconel 620, and titanium, Ti64. Now, there are a few honorable mentions that I'm not going to dive into. One is Magnum Venus Products, or MVP, with its new RAM commercial systems. These are large format for material extrusion of two-part thermoset materials. Digital Metal also launched its DMP Pro. This is a binder jetting solution for metal parts, and Nexa had its ZIP desktop unit that uses the company's lubricant sublayer photo curing, or LSPC. Now I'll move on to materials, starting with JEOL. It announced the launch of its eco-friendly PK5000 for powder-based platforms, and here's a sample part, which I'll get to in just a second. PK5000 is a polyketone developed by JEOL to meet its needs as a contract manufacturer, but it's also making it available to others. What does PK5000 offer? Well, what about improved strength, chemical resistance, and resilience in comparison to general-purpose nylon materials like PA12? Or it can be an alternative, maybe even a replacement, for acetal. Characteristics of PK5000 are high lubricity, phenomenal chemical resistance, high wear resistance, it machines nicely, and it can work for snap fits and living hinges. All of this at a lower cost than comparative PA materials. Now, I said I'd get back to that part, and here it is. In thick cross-section, it's nice and rigid. In a thinner cross-section, it picks up flexibility. Now, this has been my fidget toy since I returned from RAPID. They challenged me to break it, so I can take it to a full bend and give it a squeeze, and it's not snapping or breaking. And I have done this thousands of times. And with this, you get an idea of what PK5000 can offer you. And now I'll move on to Desktop Metal with its DuraChain photopolymers, a first of its kind. DuraChain uses a material chemistry process known as photopolymerization-induced phase separation, or PhotoPIPs, to deliver breakthrough material properties that compete with thermosets. It can produce tough parts, resilient parts, while eliminating the need for a two-part resin. So how does it do that? Illumination by the UV light source induces material phase separation. So the one material goes into the machine, but during the process, it actually separates out into two different parts at the nano level. And then in the machine, it cures to polymerize. So one material goes in, but it behaves like a two-part resin. One of the advantages beyond material properties is that it has an up to 1 year pot life. It was developed by Texas-based Additive 3D, which was acquired by Desktop Metal in 2021. PhotoPIPs has been studied for many years, but AAM struggled because of its high viscosity. Now, they've addressed that, and this material is printable on the eTech Extreme 8K. Some materials that they named at the show: elastic tough rubber, or ETR for short, ETR 70 and 90 indicating the durometers, and also free foam. This is an interesting material enabled by photopips. It uses a heat-activated foaming agent, which is only possible due to the photopip's strength and capabilities to withhold the bubbles created by the foaming agent. Now, so that's contained within the strength of the material, but what is really quite interesting is the parts are printed smaller than what is desired for the final design. Then you take the part, and in a secondary thermal process, the part expands. That foaming agent kicks off and it introduces air pockets within the part. Notable benefits are that it has a softer feel than that achievable with lattices alone. It's lightweight because of those air pockets, and it can be shipped in the printed size, meaning smaller, and then expanded when it arrives at its final destination. So, printing at a smaller size, it also effectively increases your build capacity. Formlabs expanded its material lineup with its entry into polyurethanes for its Form 2 and Form 3 printers. On the opening day of RAPID TCT, it announced PU650 and PU1000. PU650 has impact resistance with pliability. It's identified for performance applications such as hinges, snap fits, connectors, as well as wheels, bumpers, and grommets. On the other hand, PU1000 is semi-stiff, creating unyielding parts, which can be used for jigs and fixtures, enclosures, and sturdy consumer products like buckles and bike pedals. Now we're going to shift gears into software and a brand new player spun out of the University of Michigan. That company is called Ulendo. What it launched at RAPID TCT was FBS, which stands for Filtered B-Splines. Its promise is 2 times the speed and 10 times the acceleration for FFF printers. But it's also applicable to other printers. This software solution was born from work to overcome machine tool vibrations, and its plans are to extend FBS to robots, machine tools, and other types of 3D printers, or really anything that mechanically moves a printhead. So how does it work? It's algorithmically manipulating the toolpath to compensate for vibrations, essentially serving as a translator between the commands for head movement and what you want as the output or the modified path. The bottom line, it prints fast while retaining quality. But note, Ulendo will be offering FBS via hardware OEMs, so you won't be able to buy it directly. Now let's move on to Castor. And let me start with a question of what is a good candidate for additive manufacturing in terms of design? Can you identify them? Can everyone in your organization that needs to identify them do so? Well, Castor has a software solution to assist all those in your company that still don't have the eye for what makes sense. It takes a look at your parts library and reports time and cost of AM processes versus traditional options. And it makes suggestions on changes that could make that part cost and time effective, with recommendations for design modifications in the categories of weight reduction, part consolidation, and others. It's a strong solution when you have a tool that part by part does the analysis, but Castor tools let you interrogate the entire assembly in a batch operation that does the analysis for the complete bill of materials. Now, what's new? Castor's been around, so what's new? Now you can do this analysis and recommendation from 2D drawings, so you can capture intent for additive manufacturing for all of those legacy parts. No 3D model required. It also added supply chain costs in its calculations and determination of CO2 emissions. Presently, the CO2 emissions is based on shipping, but they will expand the CO2 calculations to include more contributors going forward. And Materialise announced CO-AM. This is a new software solution. It's an open platform or open architecture that allows integration of cloud-based software from Materialise and other vendors. It uses a data lake approach where these disparate solutions can communicate amongst themselves. Cloud-based access for a full range of software tools spanning plan, manage, and optimize at every stage of the AM process. So it's offering seamless access to production data. CO-AM is an AI-powered learning platform that breaks the disconnections that we've had in the past. the disconnections that impede workflows and impart inefficiencies. So what does this mean to you? Well, you can keep using your preferred solutions while working in a unified environment. Now, Castor, who I just mentioned, is participating in the CO-AM platform. Also, AM Flow is a partner. Just to show you the end-to-end solution that's possible. Castor for picking the parts that you want to use for additive manufacturing. AM Flow is all about part handling after the 3D printing operations are done. Now on to post-processing. I got two companies for you. Dimension was there to talk about the PowerFuse S. They've upgraded and tuned their vapor fuse surface technology, which is vapor polishing, to handle flexible materials such as TPU, thermoplastic urethane, and polypropylene. The current platform is tuned for compatibility with Lubrizol's S-Stain 3D TPU, and it already works with other TPUs like those from BASF. That version of the machine of PowerFuse S is available immediately. Now what it announced but will launch later this year, most likely at Formnext, is PowerFuse S PP. They're currently qualifying customers for a pilot phase, and they claim injection molding like finish and functionality of polypropylene parts. Key development to achieve that is new solvent formulations. Second, in the post-processing category is AM Solutions with its C1 system for automated support removal from photopolymer processes. Currently, those are the polyjet-like processes where you are encasing your part in a support material. This C1 steps up to meet the strict industrial standards and fulfills requirements for process stability, consistency, efficiency, and traceability. The machine is compact and plug-and-play, requiring just a 230-volt outlet. Part of the secret sauce is the immersion compound that's adapted to individual materials. The company states that the C1 will work with complex shapes, delicate parts, and very thin walls. It also features auto-replenishment of this compound and sensors for bath contamination to signal when you need to change the solution. Now on to scanning and inspection, and I've got just one to mention here. Now, actually at RAPID TCT, there were a number of scanning and inspection solutions. They've been part of the event for many, many years, but they really came out in spades for 2022. Now, the one I'm going to highlight is Direct Dimensions. It unveiled its PASS, Part Automated Scanning System. This is a unique system that captures parts in 2 minutes and then automatically processes a 3D model in just a few more minutes. These models are dimensionally accurate and have high-resolution colors and textures. According to Direct Dimensions, applications include cataloging parts for visualization and review, creation of 3D CAD models for 3D printing, and inspection of additive manufactured parts. And then the last item I want to mention for the What's New that came from RAPID TCT, this one actually didn't come from the show floor, it came from the stage. SME has partnered with Women in 3D Printing with the goal of building a more diverse and inclusive AM workforce. These two organizations will combine experience, programs, and networks to conduct 4 initiatives to close skills gaps and attract new talent, getting people to choose a career in 3D printing. Those 4 initiatives are co-produce the next Women in 3D Printing TIPE conference, which stands for Technology, Industry, People, and Economics. Number 2 is to showcase women in 3D printing at RAPID TCT 2023. Number 3 is a joint next-gen mentorship pilot program. And number 4 is to co-author an annual Diversity in Additive Manufacturing report. Well, that's it for my recap of RAPID TCT 2022. This was and will be a not-to-be-missed event. So let's do it again in 2023. Don't miss out. In 2023, the dates will be May 2nd to 4th, and it will be held at Chicago's McCormick Place. As I learned this year, you'll want to bring a friend to divide and conquer and plan to be there for all 3 days to have any hope of seeing it all and learning from all of the information that is exchanged.